friends and hello student. My name is Ashok Sigala. In this session, we learn the array and pointer in C language. So first, I share my laptop screen and here fix the position so you can watch better my video lecture. And here Turbo C++, I double click and take some process. And now just is open. Yes, and Alt F file menu taking new file. And here our call uh, write write a program to print 1D array, one-dimensional array using pointer. Yes, that is our target. So only we have to print using pointer and how many techniques. So yes, I start directly to our header file and that is a stdio.h, then conio.h. Yes, and then void main. Yes, and then opening closing brace, and here we can define the like integer x of file. Okay, and then asterisk p, that is pointer. So yes, first we can scan, so we can require the I as a our index. Okay, and then clear the screen. Yes, and then here one shootable message. So how many techniques to print array and using also pointer. So enter 1D array elements, that type of message, and here we can scan. Yes, but in the for loop, not directly, but we can take some number of row. Okay, that we can after that. So let us take first for loop. So yes, I equal to 0, I less than 5, and then I plus plus. So here we can first print the index. Okay, and then you can say that uh, x of percentage d, and then print I, and then scanf function is now required. So percentage d and m% x of I. Yes, and then here closing brace, and now we can start how many technique to print 1D array and using also pointer. So yes, I copy and paste and get sketch, and yes, I first save this file. So I can say that enter that 1D array means one, we cannot give the first file name. So a1d, and that is we have to print the elements. So yes, pointer. So point with pointer py and dot c. Yes. So yes, first technique you have to know very well. You have to already we have to use in our coding. So yes, that is our first technique, x of I. So that is a, so I here we can prove that array and pointer is a related concept. Means array without pointer and pointer without array we cannot perfectly understand. So both array is working internal pointer and pointer working internal array. So that is a first. Let us take, and here I provide the slash n. So yes, check and compile. Yes, there is no any error. And let us take first very simple. So we can scan 5 value. So that print, yes. But here, yes, here required that is a index only. So here not element is print. So yes, now and also here provide the slash n. So first we can take our simple that usually have to print. Yes, let us take. Yes, I give 1 to 5. Yes, that print. Now here I can prove the array and pointer is similar, and here total 9 technique. Yes, so 9 technique or 9 way we can print the 1D array using pointer. Okay, so yes, in how the full form of this, yes, so x of I, how it's actually print in internal. So we can write that statement. So I first here technique. So x of I we have to write. So internal that statement asterisk parenthesis x plus I, that is a explanation internal in this conversation. So both statement is equal. So here x is a array name and it is store the first byte of element. So x of 0, yes, here we can write like x of 0, that address store the x, the array name itself. So that is a like pointer. So array is a working internal like pointer. So that first byte of that array name. So like here I assumption 1000 address of first byte. So X name store the 1000. Yes, that is a I can that is a paperwork means board work. So here first of 0 that is a address, and here like or we can store 1 or like 10 or any value. So here that is a index, that is a value, and that is address. So here we can say that that is our X of 0 element, and then that address 1000 we can assumption, and that store by X that value, and array name itself we can say that. So here we can write also this statement. Yes, so how? So here I can now percentage d, and then explanation of this statement asterisk parenthesis x plus I. Yes, so that is a print. Yes, because that is a first byte of 0 means, and I is 0. So that is a for x itself means that 1000 address which value store, because that is a print is 1. Okay, we can assumption that 1 store and 1000 is address of first byte, and then we can print all 9 technique as it is. So I just remove this because that is paperwork. So here we can, yes, now you can look here. Now I can explain to here. So here we can, that is a address, yes, and plus I is index. So plus in maths rules, we can before or right and after. So there is no difference. So after we can use the third technique. Yes, let us check first that print perfectly or not. So yes, I run, yes, that are 2 times 1D array print. So that is a yes print same. So now I use third technique, means the third time. So here I comma, and then I bar means we have to take outside of I and then inside the X. Because here we can prove in maths rule, you before the plus and after plus there is no difference. So here that fourth technique I also write, and that is the explanation of this statement. So again asterisk parenthesis, yes, and then first I and then X. So that is a full form of means that statement. So that is the explanation in this statement. So before or after plus sign is no meaning of fair, means that the value is not changed. Okay. So yes, that is a fourth technique we have to let us take that perfectly work or any error. Yes, no any error. And let us I give the same value. You can give yes. So 4 times same element is print. Okay, so that is a fourth technique, and now fourth technique given by the pointer. So yes, we can prove. So here I p equal to x, because we have to prove that x name itself is a first byte address, and you can also write like p uh, ampersand, yes, ampersand and x of 0, that is a first byte of address. So that both statement is equal. Yes, because array name itself store the first byte address. So we can write also this type is the same meaning of p of x, because p is an integer pointer and x is an integer 1D array, one dimensional array. So here I just give the comment line. You can write also this or use this, no any meaning of change. So let us take this print, and here I give the percentage d, and here we can print the p of I. Yes, so that is a fifth technique, and you have to know p of I we can write. So again parenthesis asterisk parenthesis and p plus I, because I and p same base first byte of that is base address, that known as a base address. So here I give percentage d, and that is percentage d. So there are 8 techniques we have to cover. 1, 2, 3, 4, 5, 6, 7, and 8. So what is now next to? Yes, our we have to outside I and inside the P, and then again that asterisk, yes, asterisk and parenthesis I plus P. So that is a 8 technique. We can print our same element. Yes, let us take simplicity give the same element, you can give this different element. Yes, so there is a 8 time we have to print the same element. So we can see the 9 techniques to print 1D array using the pointer, and 4 technique given by itself, that is a array means that is work in the pointer form. Yes, here we can prove that array work in the pointer internal memory. and 4 technique provide the pointer itself, and 4 technique provide the array itself. So array and pointer is a correlated concept. And 9 technique last, but here we cannot use because you have to know asterisk p, that is a print element, and pi plus plus, but here we cannot use in that because that disturb all two. So here we what to do? So again I copy this for loop, and we can print in separate way because that is a disturb to all element. So yes, here I give the percentage d, and yes, here we can also print the index of p parenthesis, yes, and then print I, yes, and then percentage d and element. So asterisk p, yes, that is ninth technique. Okay, and here what to do? Here comma and p plus plus pointer, we can use arithmetic operation. So here that is known as a scalar. Scalar means that the 2 byte jump because integer pointer. So every time p plus plus and next element print by this asterisk p. Asterisk sign refer the element inside that address point to. So that is known as a pointer. So if you not watch my previous pointer in C language, so you first watch, and that is a same statement. Yes, here I give the comment line. Yes, and here I open this statement. So yes, any difference, or let us check. I compile. Yes, there is no any error, and let us give by same element for simple. Yes, so there is a ninth technique. Yes, so here 8, and then p of 0, that is 1, p of 1, that 2, p of 2, that is 3, and p of 3 4, and p of 4 is 5. But we can give 1 to 5. You can give any element. So yes, here require the slash n. Yes, here we can also provide the slash n. So that print separately means next vertical line. And here I give different value, not same 1 to 5. So give any value in elements. Yes, so that is the same. So array is a pointer and pointer is array, that is work in internal memory, we can say that. And total I cover in 9 techniques. So that is very important. And here we can also prove this both statement is equal. Yes, here you can write of this because array name itself is a first byte 0 bytes address. So that is a best technique. Yes, and that is a just I can use, but here we can again comment line. So I give just the idea. So p equal to x is a p, and x both are pointer because array name itself store the 0 byte address. So array is internal work as a pointer, and pointer work in internal is a array. So we can prove like Pythagoras uh, yeah, like in that we have to in 10 standard. So we can prove that that experiment. So that here we can also print 9 techniques. So array. So array using pointer, we can print the ninth way. Ninth technique is that. So here I cover all technique. Yes, let us check. So first our simple technique. Yes, that is I, that print only index, but here x of I, that is a explanation internal this form. So our element is print actually like our x is a first time like 1000 that address, and then plus sign, and then I is 0. So 1000 asterisk means refer that value. So yes, how it's print I just explained. So yes, let us check one here. I draw one table format. So like x, yes, and that is element, and here we can give index 1, and then 2, and then 3 because index start with 0, and 4, and then our element like store any element. So here we can give like 9 to, yes, any element I give. So 3, not 3 because that is index, and here also I give some different value. So like 7, yes, and then here 5, and last we can store like 6. So that is a, we can say that index. Yes, I just draw for you. So that is index, and we can say that that is a value. Yes, and here is a address. So here like 1000. Yes, but I some gap, and then 1002 because that is a integer pointer, so 2 byte shifting, and 1004. Yes, so I again give some blank because that and 1006. Yes, again I give some blank, and then 1008. Yes, So that is a this last element. So that is a first is a index, and here is a address. So yes, address. So address is a store in X. Yes, here I prove, and that is known as a BS, base address, first 0 byte element. Means X of 0, that store, like we can take here bracket. So that is a index. Yes, also you can write all of these, but X of 0, and that is a base address, and that store in the X value. Yes, X is a name of array, and that store the first byte of element of that array. So here we can take the like p equal to x, that is a x address store in the p, because p is a pointer and storing the address. So here p and x are both equal. So here also 1000. So here we can print the ninth way. Yes, now you can explain. So here what is the things happen. So 1000, yes, and plus we can say that like a 0. So that asterisk means that value, then I plus plus. So 1000, that 1000 not 1, yes, because that integer pointer. So I plus plus, so that 1002, because that is a scalar, that increment, that integer data type refer, and that is 2 byte shifting. So here like we can say that 1000, and then if p plus plus, or we can say that x plus plus, x of I. So I is plus index, and that 2 byte shifting, then again 2 byte shifting, and then again 2 byte, and then again 2 byte. So that is I can explain. So how its print is array. So here first is 0i, so there is a itself 1000 address print. Then I plus plus, so 1 is not plus, but 2 byte is shifting. Then 2 again, so that is a 1004, again 2, so 6, again 2 I plus plus, so that is a 6 to 8. So that is our last element. Okay, because we can start the 1000. So our last means that is a x of 5, we can assumption only 5 element. Okay, and now that is a print all element one by one. So that is a only paperwork for reference for you, that is a very important. So I just cut this all, and here I for your reference, that is internal happening. Okay, that type of thing happening. So here we can print the ninth technique of 1D array, and also 2D array is a same number of means that we can different type of technique print. But here is a 9 technique I print the, and we can prove the x or means array name itself store the 0 byte address, or p of x, that is store the first byte of. So here x or and p are both same refer is a first byte element. So here we can p plus plus. Okay, so then all element print one by one. Yes, here we can p plus plus. So that is a 2 byte shifting, and that asterisk means that refer the its value. So that is a, I think you have to understand, and just I remove. So all over 9 technique, because in maths rules you can before or after plus, and your variable you have to change, that meaning is not change. So here we can I in outside of subscript, and inside the x is subscript. So that is a, that full form is I plus x, and then asterisk, so its value point to that address that value, and then p of I, then expand this statement, like here we can x of I expand this statement. So here asterisk, then p plus I, and we can again I outside of subscript and inside the p, and that is a expand of this statement. So that is value is printed. So yes, now I conclude this session, because array and pointer is a correlated concept in C and C++ also. Same concept is work. So here 1D array using pointer, and we can print the ninth technique, 9 way we can say that different. And here I elaborate all, that is a index, that is a value, and that is address. And that first address known as a base address. Yes, BA, not BS. Yes, base address. Yes, BA. BA means base address, and that store array name itself, and that is a store by X. So we can assign the p equal to x. So x is a always refer to the address of other element. Here is a pointer, so we can that point to array on first byte, and then after 1 plus plus, so that is a jump 2 bytes every time. So that is a, and that concept known as a scalar. that jumping pointer to refer that data type. Here is an integer, so 2 byte. If character, 1 byte. If float, 4 byte. And double is a 8 byte, and long double, so 10 byte jump directly. So that is a scalar value, that known as a scalar, that known as concept in C language. So yes, I close this session. Yes, I think you have to understand. So here I print the ninth way 1D array using pointer and simple. First we can take simple, not you here we can use the first pointer. So for technique give the itself is a array. Yes, and then pointer is start, and then also for technique give to our element, and ninth technique itself is a pointer, so asterisk p. Yes, here we can asterisk p, so that is a ninth technique. We can print our 1D array same element to different way, 9 way we have to convey to our print to our element. So yes, now I close this. You write this, all these thing is very important for your logic. And here I complete my session. So yes, write this program to your C notebooks and close this file, alter F3 function key and quit. So yes, subscribe my channel Ashok C Jalakadi, press the bell icon to never miss any update, and thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.